Hi, everyone. Good to somewhat kind of see you virtually from a distance. As Amber said, my name is Thaddeus. I'm a planetarium educator here at the Bell Museum. I'm actually in our planetarium right now, the Whitney and Elizabeth Macmillan Planetarium. It is live, at least right now as I'm doing it, just to prove that. I'll bring the lights down a little bit here, and we'll make our dome a little bit more impressive to see behind me. But today I will not be using our dome to explore our sky as we do during our shows here at the planetarium. But for all of you here, I'm going to be using Stellarium. Of course, if you've tuned in before, you know how much I love Stellarium. If this is your first time, oh, get ready. Stellarium is a really fantastic piece of software. It's free and it allows you to observe the sky from, well, pretty much anywhere on Earth that you'd like to. Of course, we're doing it from right here in the Twin Cities. So down in the bottom left of the screen, we've got Earth, Minneapolis, and rough altitude there, kind of off. And we are looking at the night sky. We've got our time and date up. We're looking at the night sky on the 21st today, and we're looking at about 8:53 here. Now, looking at our sky, at 8:53, we are going to talk about the October sky here, but I'm starting here in tonight's sky, because for those of you who are watching it live right now, or at least in the next couple hours, you are in luck. It looks like we'll have a clear sky tonight. That's first lucky thing. And second of all, we'll have a really great pass overhead of the International Space Station. So if you go out tonight around a little bit before 9 o'clock here, again, 8:53, and you look to the west, we've got a W down at the bottom of our screen, and you look in the sky for a bright point of light. It will appear low to the horizon, but rising upwards at a bit of an angle going towards the north. And I'll go in how to find the north here in just a second as well. But that bright point of light that we can see is this one moving right along here. Make it a little bit slower. This is the ISS, the International Space Station. So what looks like a bright point of light moving above our heads for several minutes tonight is actually a human spacecraft. I mean, for lack of a better word, it's more than just one spacecraft though. The ISS is about the size of a football field. It includes a dozen different modules, and it's been our permanent space habitat for the last 20 plus years. Right now, there are 7 astronauts on board the ISS, carrying out experiments, learning what it's like to live in space, studying everything from how the human body is affected to space, but also turning instruments out into the rest of the universe, studying galaxies and supernovas and everything out there, as well as looking back right down here on Earth. The ISS is able to get beautiful, incredible images of the Earth that just for their sheer artistic aesthetic power are amazing. Now I'm able to find out when this is happening because NASA publishes all their data, including when the ISS passes overhead. And Amber should have a link there. She's putting in the chat that where you can put in, it'll be a link, hopefully the one right to St. Paul if you're here in St. Paul, but the spotthestation.org, where you can put in your own information, your city, your zip code, and it'll tell you when the ISS is going above your head. Now, it's really great. The next couple weeks, about the next week and a half or so, the ISS is all the passes here in the Twin Cities are at night. So if you're a night owl, this is a great few weeks here to see the International Space Station going there at 17,500 miles per hour above your head. Now, as we look here in the sky, we are going to talk about October, so I'll skip forward just a few days here. Well, I guess about a week. We'll go forward to October 1st, and we'll go backwards in time a little bit. I'm going to go to about just about 8 o'clock or so. Now, as we go through October, the sun will be setting earlier and earlier, just as Amber said, it's already started to do that. So by the end of October, 8 o'clock will be very dark, but you can even go around 7 o'clock or so at the end of October. But here at the very beginning of the month, 8 o'clock is good. The sun will be pretty low below the horizon, so we'll see hopefully a lot of stars. Now, if you're here inside the Twin Cities, I will admit you might not see a ton of stars. I live right here in the Twin Cities, and I know that feeling. We have several dozen stars, though, that are very easy to pick out in the sky. And of course, if you get away from city lights, which I highly recommend, there is a lot more to see up there as well. But I mentioned one of the first things I want to point out was how to find north in the sky. Many of us are very familiar with how to do this, and it's one of the first things we learn how to do in the sky. Of course, you all already know it. You just go outside and you look for those giant red letters all around the horizon. And there you go. You found your directions. Now, on the off chance that you don't have those giant red letters, don't despair. We have stars. In particular, the first group of stars you should look for, a lot of you probably already noticed on the screen, is the Big Dipper. Now, to see this, just really look around you in the sky. Don't look for 7 bright stars. The Big Dipper will sort of pop into field of view once you do spot it. 7 bright stars with the handle here, 3 making up the handle, and 4 making up the bucket of the dipper. The more lines, you can connect more lines to it, as Stellarium has done for us here. This makes up the constellation of Ursa Major, the larger bear. And this is one of the constellations put together by the International Astronomical Union. Now, as we go along here, I'm going to be pointing out a lot of International Astronomical Union constellations, but they're not the only ones up there. I'll come back to that in just a second. But from the Big Dipper, if you travel upwards from the 2 stars in the bucket and you go forward about 2 hand lengths, which Stellarium is marking out as about 30 odd degrees here, this will point you, these 2 stars here in the bucket of the Dipper, they will point you to this star here called Polaris, or our North Star. And that is the end of the Little Dipper, or Ursa Minor, the smaller bear. And this Polaris is truly our North Star. So as we see it here, looking in our sky, it's right there. That's cool. But if we get time moving forward, we're going to moving pretty fast here. We can see these stars all moving across or around the sky. And they're very slowly, or actually very quickly here, setting in the west, and they're rising up over in the east. Now, they're making this apparent motion. They're not truly moving as we watch over the course of the night. They're not really moving enough for us to see. However, we are spinning around. The Earth is spinning around. And as the Earth spins, it causes that motion above us. But the Earth is spinning around. It has a center axis, the center pole of the Earth. And that very center of the Earth, it points upwards at a point in the sky, and it points, in fact, right there to Polaris. So Polaris is right above the North Pole of the Earth, and that's why it seems to stay in one spot throughout the night as the Earth spins around. If this is sort of a big concept, if you hadn't heard about this before, if you just learned about this for the first time today, there are some easy ways to visualize it. You can use a top, for example, the little toy, a top, and you can spin it around. And if you look at that top spinning around, you spin it really, really well. The very spindle of that top, the thing you use to spin it, looking straight down on it, you'll notice the spindle isn't really moving around, but the outer parts are. And so that top is kind of like the Earth spinning, and the spindle of the Earth is the axis of the Earth. It's staying in one spot, and you looking right down at it, you're staying in one spot. But if you're looking at the bits around the top there, they are moving around, and that's the other parts of the Earth where we are. So right where we are here in Minnesota, we're spinning around at about 1,000 miles, about 900 miles per hour. And that causes, again, that change we see in the sky. Now, we're going to go back here to about 8 o'clock. Ooh, a little too fast, so a little more accurate there. About 8 o'clock here, and we've gone forward to the second. That's fine. The sky changes a little bit day by day, but one day versus the other, not too bad. Oh, and I actually realized I'm here at 10 o'clock, so we'll go back to 8 o'clock there. So we found Ursa Minor, Polaris, the Big Dipper, Ursa Major. Looking in between, and you may have noticed along the way there, I turned the atmosphere of the Earth off, so I'll turn it back on here. Looking in between the Big and Little Dipper, there is another constellation kind of winding its way around here, going through here and down and around, ending at a group of stars right over here. This is where we find the constellation of Draco, or the dragon. Get just the dragon up there. Now, Draco is personally one of my favorite constellations, and it's one of my favorite constellations because, well, for 2 reasons. First of all, as a kid growing up, I really like dragons, as I think many of us do. But also, as I started to learn more about the sky and started to look for deep sky objects, I found that Draco contains maybe the most beautiful, to me, the most beautiful deep sky object of its class. And it's located right in the neck of Draco. So to find it, you can look for the crook, the round bit of the neck here that bends around. You can also find Ursa Major, or excuse me, Ursa Minor again. And if you go from the bucket of the Little Dipper and you travel crosswise this way into the neck of Draco, right around in the same spot in the sky, well, you'll find something very, very cool. In this part of the sky is where you'll find, oh, excuse me, I'll come up a little bit, is where you'll find the Cat's Eye Nebula. This is known as a planetary nebula, and it is a dead star. So we're looking here at a star like our sun that has reached the end of its life. It's expanded outwards and it's cooled down. The very outer layers have come off, but the very inner core has shrunk down into a white dwarf. And that collapsed remains of the white dwarf is now energizing all the gas around it, putting out all this light and allowing us to see it. It's an incredibly intricate structure. As you can tell, this is an image, I believe, most likely from the Hubble Space Telescope, or possibly Chandra or Spitzer, in fact, based on some of the details we're seeing here. And it's showing us the outer layers of the star, the first parts that came off of it, and the very bright inner core. Now, if you happen to get your hands on a telescope, or really your eyes on a telescope, you would need a telescope to see this. And it's the bright central core that would stand out, this beautiful blue-green color coming from oxygen in the atmosphere of the star. And this color is something you could see yourself. It looks like a little turquoise diamond in the sky. It's absolutely stunning to see. This large scale of it is much harder to see. You do need to be working with a research grade telescope like the Hubble to get an image like this. And unfortunately, we aren't able to put our eyes up to the Hubble, but it has magnificent cameras that over the past 30 plus years have given us incredible views of the heavens. All right, so that is the Cat's Eye Nebula in Draco. But as I bring up the name again, Starry brings up all of these deep sky objects. So our sky is filled with all sorts of different objects, from dead stars like the Cat's Eye Nebula to new stars being born, to collections of stars, to gas and dust, to all sorts of things. And our constellations serve as a way to find these different objects in the sky. So as we look across the entire sky here, there are constellations everywhere we look. And they're groups of stars that have been put together by people. The constellations we see here are ones from the Greeks and Romans primarily, as well as some slightly newer ones from around the age of exploration, about 400-ish years ago. And they're constellations that actually mark out different areas in the sky. So these lines in red that we see here. So the constellations in this sense refer to the areas of the sky, these bounded areas, these boundaries, and they're ones put together by the IAU. I mentioned them a few minutes ago, the International Astronomical Union. Back in about 1910 or so, 1908, 1910, the IAU group of astronomers sat down and they came up with a way to split up the sky into different parts. And as Western astronomers, they used Western constellations, Western groups of stars. So Ursa Major, Minor, Draco, Hercules, we can see there, Bootes, we can see Cepheus and Cassiopeia, who we'll come back to in a second. They were drawing on, these Western astronomers were drawing on their own cultural history and traditions. But these aren't the only people who've looked at the sky. Everybody all across the world and across time, every different culture has looked, every different person in every different culture has looked at the sky. And for example, right here in Minnesota, our own Ojibwe people or Dakota people, they have their own constellations, their own groups of stars, and their own stories and histories that they tell through the stars. And in fact, right here at the Bell Museum, if you come visit us, I'm here right now, but if you come visit us, it's really worth keeping in mind that we are sitting right here on Dakota land, as is really all of the Twin Cities, the University of Twin Cities campus, and a great deal of the Twin Cities. And it's a really important thing to acknowledge that history that is part of the history of Minnesota and becomes part of the present today. Ojibwe and Dakota people are still around, and they have a lot that they can teach us through their own traditional knowledge systems. And we do here at the Bell Museum, we do offer, we do waive our admission for Indigenous peoples. So if you do get a chance to come to the Bell Museum and you wish to identify yourself, then I highly encourage you to do so. And I hope to see you here in the planetarium as well. Now, coming back to our sky here, and some of these different constellations. Well, actually, let me bring up one other thing that I wanted to mention here. One of the great things about Starry is that it has a large catalog of different sky cultures, what they call star lore here. Now, this is everything from Arabic constellations in the sky, which have some of the same shapes as picked out here, but different names and histories, to different Chinese constellations. Chinese astronomers put together over 100 different constellations, different star groupings in the sky, splitting up into many different parts. Going back to Egyptian constellations, which from what we know of this culture is, again, some similarities. We see similar stars put together. And truth be told, out of all these constellations, we don't have complete records of all of the things that they saw. And it's almost assuredly that Mayan, Incan, Mongolian cultures, they filled up the sky with constellations just like Western astronomers did. Much of that knowledge, though, has been lost over time. For example, coming back right here to Minnesota, Ojibwe or Dakota, Lakota peoples looking at the sky, filled the sky with constellations, but due to a history of colonization, due to a loss of knowledge, accidental losses, people passed away or had that knowledge taken away from them, they filled the sky up with different things. What we see is the Big Dipper was known, for example, as the loon. We know that. The Big Bear here was the Fisher. And these constellations marked down Stellarium. These were put together. Stellarium is an open source free program. Anyone can contribute to it. And Dr. Annette Lee, in particular, along with William Wilson and Carl Gaboy, they helped put together this particular knowledge set into Stellarium. They are indigenous peoples. Dr. Annette Lee is really amazing. She runs Native Sky Watchers, which I highly encourage you to look up. And they've worked to gather what remains of this traditional knowledge, and to share it with people. So I highly encourage you to look up Native Sky Watchers, to go through Stellarium here and learn more about what the Ojibwe, the Anishinaabe people saw in the sky. Today, though, I because I'm not indigenous, I'm going to be sticking with the Western constellations. These are the ones that I would say I personally feel a heritage towards. They're constellations I grew up with. If any of you know H.A. Ray, who did Curious George, he also did constellation books. Those names are just skipped out of my mind right now. And they're one of the ways I learned about the sky growing up. So I have my own connection to the sky here with them. In fact, I think I was seeing there. Let me see if I can bring that up. We'll go with these H.A. Ray constellations just for today here. Oh, actually, we'll not, because the images don't come up with that one. Not all of them have images, unfortunately, with them. And I do like the images, so I'll stick with what we call the default Western ones here, just for the images. All right, looking at the sky though, coming back to our sky. Well, we've got all these constellations marked out. Let me pick out a couple of them here that are going to be visible and well seen throughout the month of October. Looking here to the northeast, we're here near the beginning of October. We can see our time and date here. I'm going to go to a little bit more mid-month, just to get some of these higher in the sky, make them a little bit easier to see. But looking, if you found the Big Dipper, you found north, right? That was one of the first things we did here. Well, I guess I did it over in this screen. Maybe you were following along. I hope you were. Stellarium is freely available for everyone. We found the Big Dipper and the Little Dipper. There's Polaris over there, which is north. Looking a little to the northeast, we have another bright grouping of stars. It's very easy to see. I pointed out earlier, it's the constellation of Cassiopeia. Greek mythology, a very vain queen, and she was punished for her vanity by being stuck up on the sky on her throne, and she was turned invisible. So in fact, all we see of Cassiopeia now is her throne circling above us in the sky. Now, Cassiopeia helps us find another constellation coming in the direction that the top of this, if you sort of tilt your head to the right, it looks like an M. Look, coming off the top of the M, these two peaks here, coming just sort of straight over from these two peaks, we can find two bright stars here and here, which mark out the small, well, depending how you draw it, it can be smaller constellation of Andromeda. Now, Andromeda here is in fact the daughter of Cassiopeia as the stories go. She was also punished for her mother's vanity by being stuck up in the sky because, well, the Greek gods were rather, but they weren't really fair like that. But Andromeda and Cassiopeia now can help us find a very cool object. It's already picked out here in Stellarium, but if you take these two stars in Andromeda and you go upwards from them, they'll point you to this, what we see as a fuzzy blob right there. You can also use one of the triangles of Cassiopeia, particularly this nice, almost equilateral triangle, and you can come up from it, and it'll point again to the same fuzzy blob. All through October, going into the fall months and into November, this is going to be one of the great objects to see in the sky. This is M31, or the Andromeda Galaxy. This is our closest, the closest major galaxy to our own, although there are some smaller irregular ones closer. But this is a spiral galaxy, quite a bit like our Milky Way from what we can tell. But the Andromeda Galaxy is only about 2.5 million light years away. So it's just within spitting distance here. And it's getting closer. The Andromeda Galaxy is moving towards the Milky Way, or rather, we're moving towards each other. Our gravitational effect between the Milky Way and Andromeda galaxies are drawing us closer and closer together at about 70 miles per second, 70 miles per hour. We're getting closer and closer. And in just a short while, our two galaxies will collide and merge together. This will happen in just about 5 billion years. So set your watches now. And over that course of time, the Andromeda Galaxy will be appearing larger and larger in our sky. It'll be even easier to see as it does, as it gets closer, of course. But even right now, if you head out in dark skies, an hour away from the city, well, 2 hours away from the city, I'll make sure I give myself some room here. About 2 hours away from the city, way away from city lights or any sort of light pollution, you can see the Andromeda Galaxy very faintly with your own eyes. No special equipment needed, no telescopes, no binoculars. But if you do get your hands on a telescope, it is a little bit easier to pick out the Andromeda Galaxy as well. It does very nicely through a good pair of binoculars, going by like 10 by 50s there or something, to get a nice wide field of view, to capture all of this, of our cosmic neighbor. Now, coming off of Andromeda, there is another constellation. In fact, this star right here, Alpheratz, is shared with another constellation. And it's a constellation that you can see by finding a simple bright square in the sky. So these 4 stars here, very easy to see looking over here to the east in our early fall sky. This is where we have what's known as the fall square, very cleverly named. But this marks out the constellation here of Pegasus. Now, Pegasus to me kind of looks more like a squid, like an octopus going through the sky there, but is imagined as a winged horse, or at least one half of a winged horse. Pegasus here as well has some really magnificent deep sky objects. In particular, my absolute favorite, coming off the nose of Pegasus, the star Enif, which means the nose in Arabic. Coming right off it, about 3 finger widths away, is where we find M15, noted here as the Pegasus cluster. This is a globular cluster. It is a collection of approximately 100,000 stars, approximately 30,000 light years away, and approximately 12 billion years old. It's a magnificent sight. In fact, all globular clusters are really magnificent, but M15 is I'd say one of the best ones. Definitely one of the easier ones to find. It's very nicely located there. We see it off the nose of Pegasus near that bright star, although it's truly nowhere near that star at all. It is, though, part of our Milky Way, though. The Andromeda Galaxy we saw just a few minutes ago, that is outside our Milky Way, really not part of our local area here. The M15 that we see here in front of us, this is also, in a sense, part of our Milky Way. It's outside the main disk of our galaxy, 30,000 light years above it, but it's orbiting around the Milky Way. It's very strongly held by our galaxy's gravitational pull. So it's part of our own home galaxy here. And again, it's a beautiful sight. You will need at least a pair of binoculars to see the M15 here. It will look kind of like a bright puffball there in the sky, or kind of like a bright cotton ball of stars. A small telescope going 3-4 inches across will give you a nice view. And of course, larger ones will get you even better views there. Now, one of the things about our fall sky is that when we are looking for, when we're looking across the sky, we have a good number of bright stars, but the brightest stars are starting to set. They're becoming less visible. And that's because the brightest stars are found near the main disk of our Milky Way, which we can see marked out here. Now, the Milky Way traveling up and above us here in the sky is a beautiful sight to see. And during the summer months, we were looking at the core of the Milky Way, which is right over in this area here. But that core is moving lower in the sky, and that's because the Earth is moving around the sun. And as we move around the sun, we're looking out at different parts of the universe at night. Now, with the Milky Way leaving our sky, that's a little sad. We still have the outer, fainter arms of it going back to the north here, and the Cassiopeia, the constellation Cassiopeia, is right along that path there. But this does mean that without our Milky Way, we have a view of intergalactic space. So looking, for example, to the southeast here, this part of the sky is where we're starting to see stars that are part of our Milky Way, but with telescopes, we're looking far beyond those stars. We've already kind of done it there with M31, or the Andromeda galaxy. And looking all throughout this part of the sky is where we find all sorts of different galaxies. Coming back for a second to Pegasus, and to these two stars on one side of the square, coming down from these two stars just a short distance away with a telescope is where you can find a decently bright galaxy, not going to be the easiest one to find, but a good one for you experienced sky hunters or someone who wants a challenge, known as Caldwell 44, part of a different catalog of galaxies put together by an astronomer named Caldwell. It's a nice face-on spiral galaxy. So in a sense, kind of like our own Milky Way and in the Andromeda galaxies, spiral arms wrapping around there. But in this case, we just are able to pick out two of them here. This image again coming to us from the Hubble Space Telescope. So I can't promise you'll see it exactly like this. In fact, I promise you will not see it exactly like this. But still one of those harder objects or one of those slightly more difficult objects to see, but well worth the time to hunt down. It's named here in Stellarium as the Superman galaxy. From what I can understand, it's called that because it kind of looks like a backwards S, and Superman, I guess. I don't know. You got to wonder about who names these things sometimes. But then again, all throughout our sky here, this is where we're going to find different galaxies. We see some with rather fantastical names here, the Phantom Galaxy or M74. We see Caldwell 51 over here. Actually, let's take a look at the Messier one for a second. Charles Messier was a comet hunter, a French comet hunter about 300 years ago. He put together a catalog of objects. They remain some of the easiest ones to find in the sky to start with. So if you're looking for deep sky objects, just starting with the Messier catalog. Already done a few of them, M31, the Andromeda galaxy, M15, that globular cluster in Pegasus. And we see M74 here, another face-on spiral galaxy, much more well-defined spiral arms, though, as we can see in this Hubble image. All right, coming back to our sky, though, M74 was marked out there in the constellation of Pisces, the fishes. So what we see here, but keep it just up here, is the fishes jumping, leaping in the sky. This is a much fainter constellation. It's a little bit harder to see in the sky. You'll probably the best of luck finding the 4 or so stars at the top. And there's another one here, it's very, very faint. But these 4 or 5 stars that make up the coronet of Pisces, as I've heard it called. The V going downwards, you might start to pick out there are a few bright stars there like Alphard. But again, overall, because this part of the sky is looking away from the main disk of the Milky Way, which we can see up here in this part of the sky, the part of the sky where Pisces, the fishes, is, has much fainter stars sort of overall. But you may have seen marked out as we were zoomed a little bit in there, coming off the head of Pisces, we also do have one of our planets. So all throughout fall here, we'll have Neptune and, well, actually the last 2 planets, Neptune and Uranus in the sky. These will be sites for those with well, you can see them technically with binoculars. They're kind of hard to tell the difference though. I would recommend probably a small telescope and a good steady mount to see what will be well, in the case of Neptune here, so this dark blue spot in the sky, a really beautiful sight to see. Uranus is a paler blue, but is located as we see it in the sky, not too far away. I've got to remember where Uranus is now. I'm just gonna jump to it. Oh, excuse me, I'm way off. I'm not sure what I was thinking. Uranus is way over here on the other side of Pisces, down below Aries, the ram. But there's Uranus down here. looking like a pale blue spot again in a telescope. Both these bluish colors from Uranus and Neptune coming from methane and ammonia and nitrogen in their atmospheres, molecules that are absorbing red light, scattering blue light back to our eyes. In both these cases, Stellarium is also showing us some of the moons here, with the Oberon, Ariel, as well, because we have images of them, of the planets from the Voyager spacecraft and from the Hubble Space Telescope. There are very faint ring systems. You're not going to see the ring systems with a telescope in your backyard. Unfortunately, it's one of those things that does really require the Hubble or really a spacecraft flying right past it to pick out. For brighter planets, though, if we come over to the south here, there are two more. We'll have these planets all throughout the October sky, nicely positioned to the south or southeast. So very easy to find if you put Polaris to your backs. Also very easy to find all on their own. Jupiter and Saturn are two of the brightest planets in the sky. Jupiter, and we can see them right now in September as well if you've been out looking in the sky. Jupiter will be a little bit brighter and a little bit to the left or east of Saturn, and is a really fantastic sight. I mean, one of my favorite planets to look at. It's well worth finding a telescope if you can. Jupiter is just fantastic through a telescope. These stripes we can see here come into view very easily with a telescope. These darker belts are where gas is falling downwards into the atmosphere after it started to cool off. It's warmed up though in those white zones from internal heat inside Jupiter that's causing this atmosphere to convect, essentially, like a giant pot here bubbling away. If you have binoculars, though, don't despair if you can't see that. What's really great to see as well are the Galilean moons right around Jupiter. There'll be these 4 or so bright points of light that you can see. Although I do say or so because you don't always see 4. These moons are the Galilean moons, named after the astronomer Galileo, and they're orbiting around Jupiter. So as we watch Jupiter go, as we go throughout time, and we can see the time changing on the time in Stellarium, these moons will change their, will go below the horizon there, and that didn't work out as nicely as I hoped. We'll go back to Jupiter. Where's Jupiter? There's Jupiter. Well, here on a different day, on the 16th, we can see they've moved quite a bit around here. But these moons will move over the course of just a night. So if you're looking there at Jupiter binoculars for an hour, every couple hours, if you can, you'll see these moons change position very slightly. This is what Galileo did hundreds of years ago, giving some first proof for the idea, or against the idea, that the Earth was at the center of everything, because here he found something orbiting around something else. They are very cool in their simplicity. They are very cool to see move around there. And we see them marked out there with their names. All right, but coming back, Jupiter and Saturn are both near the constellation of Capricornus. Capricornus can be drawn in a variety of different ways. When I'm looking for in the sky, I look for just a handful of stars, 1 or 2 up here that make up one corner, another one over here where Jupiter is nicely positioned, and then one down at the bottom here. So we just get a very simple triangle that we're looking for, or that I'm looking for in the sky. There's some more stars that you can pick out that are connected together in this drawing here, whatever helps you find it. In any case, Capricornus is the sea goat, one of the odder constellations in the entire sky. One very old one, though, noted here by Greek and Roman astronomers, but they were drawing, in turn, they were drawing on the past Babylonian astronomers who picked out, or who saw this as a sea goat in the sky, a mere goat, if you will. Still kind of an odd constellation there. But down right in the midst of Capricornus, on one side of this triangle, as I was drawing it, we can also see one more planet here. We can see Saturn. I saved Saturn for what is going to be the very end of almost the end of our time here, because otherwise I would have just spent the entire time talking about it. It's a magnificent sight. Go out, see it in the sky. What more can I say? It will look, in fact, almost exactly like you see it here in the sky, which is, I think, one of the most amazing things. It looks just like a picture there. Beautiful ring system, moons going around it. It's incredible. And there is, in fact, one more planet, though, that I will point out in our sky. And And that one, though, we're going to see a little bit earlier in the evening and a little bit more to the west. So coming around to the west here and going backwards at about, making sure I get my time right, where it should be about 7:30 or so. Oh, I'm sorry, a little bit more to the southwest. A little too far to the west there. Over to the southwest, all throughout the month, we will have Venus. Now, in fact, if we go back to the first of the month, and we'll go, see our sky is very bright there. About 7:30, maybe we'll go a little bit later. 7:40 there. We have Venus in the sky right now as we look at the sky, but it will be visible all through October there. Jumping forward day by day, Venus will be sinking a little bit lower in the sky, a little bit close to the horizon. So you might, in fact, go out just a little bit earlier there. We'll go back to about 7:30. It'll still be visible there. But jumping forward again day by day, it will be finally, in fact, starting to set just a little bit by the end of the month, but still right there, moving above the horizon there. And going back to the 16th, about mid-month there, if you are looking for it, if you have a good view of the horizon, you might also catch the view of a red star right below it. This is the star Antares, a nice red-orange giant star. So if you've got good eyes, you can look for Venus. It'll be very easy to see Venus, and you can look for Antares right below it. Again, the night of the 16th, even the 15th and 17th, you might catch a glimpse. You might go from Venus downwards to see it too. So you got more than a day just to find that star if you're looking for it. Okay, but looking at our time, I see I have moved well all the way through my time here. There are dozens more things I'd love to mention. So very quickly, I'll just say we do have the Orionids going on right now and into the beginning of the month. You'll best see that during the very early morning. So if you get up around 2 o'clock in the middle of the month, look out for the Orionids, those bright shooting stars across the sky. Orionids isn't a super active meteor shower. There's only about 20 meteors per hour. But the comet that causes the meteor shower is pretty notable. It is 1P/Halley, or Halley's Comet. And if you want to see Halley's Comet, come back here in 2061, and I'll be talking a lot more about that. As well, we will be having our full moon here near the end of the month, which will be October 20th. Our full moon, never got to over here, will be our hunter moon here as we reach the end of the year and it starts to get colder. Looking back at our traditions, we know this is when we got to start, when people historically stockpiled food. Of course, we don't need to do that as much these days. We're pretty lucky, but the names do persist. All right, around this time of the month as well, October 5th, 14th, and 15th, we'll be having some talks by the James Webb expert, as well as our virtual star party on October 15th. So if you want to see some of these things through our telescopes, we'll be live streaming views from our telescopes. So please join us then. But with that, Amber, I should maybe pause for a minute here since I've been talking all this time and see where we are at. If anyone had any questions along the way, apologize for just ignoring them.
No, I don't see any questions. I think everyone's just looking forward to taking this information and applying it to their sky watching. It does look like I did check the evening skies, and it looks like although it's going to be a little bit chillier, we are going to have clear skies at least for the next couple of nights. So hopefully everyone can get outside and start applying all of this information. I did also post in the comments a link to the registration for the virtual events that you mentioned. We would love to see people at our virtual star party and where they might have a chance to be able to see some of those live telescope views and also a virtual event to learn more about what's going on with the James Webb Telescope. So the registration link for those free virtual events is posted in the comments, and we hope to see you there as well. I think we will probably sign off for the day unless you have anything else, Tad. I want to thank you once again for walking us through the monthly night skies. I know that I personally am looking forward to the cooler weather and the earlier evenings.
Well, I'm looking for the earlier evenings, but I'll pass on the cooler weather. I think if we could somehow have both longer evenings and warmer months, that'd be great, but unfortunately not going to happen. So I think, Amber, thank you so much for posting those comments. I hope for those watching, you track that information, and you head out to see the night sky yourselves. And please stay safe and have a great rest of the day.